So design of experiments is, we're going to talk a little bit just how an experiment is designed. Trying to get my first objective here. I go. We're going to distinguish between what is a randomized experiment, what we call an observational study. So just a little bit of terminology. So experimental units are individuals who are studied. So if we're trying to study how a drug medication works, then each person in the study would be an experimental unit. These can be people, animals, plants, all kinds of things, whatever it is we're studying. So it could be if we're trying to figure out if a processor works a little better, at the things that we could be looking at as experimental units, maybe the computers or something like that. So when the experimental units are people, then we frequently call them subjects. We do the same thing with our animals too frequently. The outcome or response is what is measured in each experimental unit. So if we give somebody a drug to see if it's going to lower their blood sugar, then the outcome is how much their blood sugar lowered or did it go up. So it's that change in blood sugar to be that outcome. Treatments are the procedures applied to each experimental unit. So by treatments, it's usually what we give to somebody. It's the thing that we want to know how it works. So our treatments are usually what we are researching. So once again, if we wanted to see if a drug was going to lower blood sugar, that drug would be the treatment. What we're interested in is, what does that drug do? So just kind of an example here, scientists want to determine which of 3 types of seeds will result in a larger wheat yield. So the study is going to be conducted as follows. We're going to prepare 3 identical sized plots of land because we try to keep things the same between 2 things as we can. We just want to make sure there's one thing that changes. And we want to make sure it's just that wheat seed that changes. So we want to make sure we have identical plots of land with similar as we can soil types. Each plant or each type of seed is on a different plot. We don't like put them in different places, and we randomize it. So we just randomly pick which one goes in which spot. So remember that randomization is very important to studies. Then we just start taking care of things. We'd make sure we water and we fertilize and all that stuff exactly the same way. If we can, control the amount of sunlight they get the same way. We'd harvest the wheat, and then we would measure how much growth we saw in each plot. If one type of seed produces substantially more wheat than the others, because of we try to control everything as much as we can. We try to keep the plots of land the same, the soil the same, the amount of water the same, the amount of fertilizer the same. If there is a difference between how the 3 types of wheat grow, we assume it is because of the different kind of seeds that we used. So our experimental unit would be those plots of land, because the plot of land is what we use to do the experiment on. Like we said, if it's people, we give them drugs, they're experimental units. The treatment is the different seed types. It's the thing we want to see how it changes. The outcome is how much growth we see in those plants. So a randomized experiment, this is really similar to what normally everyone knows is we use the term just experiment usually to talk about this. We have observational studies and experimental studies is usually the terminology here, but we're just going to call this a randomized experiments, which your book uses. So randomized experiment is a study in which investigators assign the treatment to the experimental units at random. So like right back here with these plots of land, we made sure that each seed was randomly assigned to a different plot. So the plots were randomly assigned a different treatment of a different seed. So that's what we mean by randomization, is those treatment is randomly assigned to whoever's in to our experimental units. If we wish to test the effectiveness of a new statin drug, we would gather patients already using statin drug. We would randomly assign some of the patients the new drug while keeping others on the current one. So usually with drug trials, you want to keep people on their old medication because you're trying not to kill people. Also because you want to see if like there's a difference between what they were receiving and the new drug and things like that. Just to point that out, because I know a lot of people think that when you do studies, somebody gets absolutely nothing, and that's not the case. What we're just trying to do is just change one thing in the study, and we want to make sure we randomize how we change it. In an observational study, is one in which in which assignment to the treatment is not made by the investigator. So usually this is because this is something we can't actually assign or for various reasons. The treatment is the difference. Okay, the treatment is the difference between the two groups that the investigator is studying. So there's still a treatment. It's just we don't assign it. So if you wanted to study the differences in cardiovascular health, so that would be the treatment would be the cardiovascular health between men and women. We cannot assign the sexes of men and women to see how things change. Therefore, randomization is not possible. So that's what I mean. We can't assign things. So I can't assign gender. Sorry, gender would have been the treatment here. That's not something I can assign. I want to look at the cardiovascular health between men and women. The only thing I could do is just look at them. I can't assign them genders and see how that changes things or anything, which that would make sense. But then you have cases like if you want to test the effects of alcohol on cardiovascular health, then in this case, it's not ethical to assign some people to be for alcohol consumption and some without, because it is unethical to assign something that we know is harmful. So sometimes that's the other reason we don't do an observational, or we do an observational study, because ethically, I don't feel okay with assigning something that's harmful to people to them to see the effects. So a lot of times the things like when we do studies on alcohol or smoking or drug use, usually those are observational studies because we do not feel okay about assigning this to people. There's just ethical issues with it. So for our first example, to assess the effectiveness of a new method of teaching arithmetic to elementary school children, a simple random sample of 30 first years were taught with the new method, and another simple random sample of 30 first graders were taught with the current method. So they're still first graders. That's all we have. 30 are being taught with the new method. 30 are being taught with the old method. At the end of the 8 weeks, the children were given a test to assess their knowledge. Children learning from the new method scored higher than the children learning from the old method. So take a minute and think about this. If you need to pause, it's fine. Determine if the study would be considered observational or randomized, and then identify your experimental units, treatment, and outcome. So the fact that we simply randomly, we did a random sample of 30 first graders and we gave them the treatment. And then we did another simple random sample of 30 students and we didn't give them a treatment. We have that randomization involved and we are assigning a treatment. We're assigning teaching methods. So here, experimental unit, who are we experimenting on? Well, it's just going to be those kids. So my experimental units are the first graders. And then if I'm going to talk about my treatment, the thing that I changed between them, I was a teaching method. So I'm going to use outcome. And then we had decided, because we randomly selected our treatment, where treatment was randomly given to the experimental units, that means that what we have here is a randomized study. So my treatment was randomly assigned. And our outcome, so what came of all this? So experimental use by first graders, I treat them with a teaching method. What is the outcome of this treatment? We have improved learning. So a lot of this we're not going to really get into kind of real in depth of this until the very end. We're like introducing the kind of the concept. This is what we're heading to is we want to be able to look at outcomes. So we're just saying that we see this improvement. We want to know is this improvement is going to be, is it really an improvement or not? Is something that we're going to look at more later. So the outcome as we progress through this course will be a little more nuanced and we're going to get a little better estimates of what's really happening here. So my next one, a study is performed to determine how smoking affects people's health. A group of smokers and a group of non-smokers are observed for several years. Scientists observed differences in health outcomes between the groups of smokers and non-smokers. So we're doing the same thing. Is it observational, randomized, experimental units, treatment, outcome? So the study performed to determine how smoking affects people's health. And what we see is that we had groups of smokers. Well, that would mean that my experimental unit would be smokers. And then the next part, so scientists observe differences in health outcomes between groups of smokers and non-smokers. Okay, so experimental units of smokers and non-smokers. So you might want to just go further and just say, all right, experimental units are just people. And what I'm treating them with is smoking. Some of them smoke and some of them don't smoke. My outcome was scientists observe differences and outcomes between. So what our outcomes is our health. So we want to know is that health improved, worse, or the same. So this one we didn't give you like exactly what the study said, but so it was a little more work getting through it. But yeah, look at experimental units. What we're looking at is people, and some of them are going to be smoking, some of them are non-smoking. So that's the thing that changes between the groups. So that would have to be the treatment, and the outcome is what we're studying is something to do with their health afterwards. Now, we didn't say anything about giving, choosing people to be smokers and not smokers. We just say we observed a group of smokers and observed a group of non-smokers. So this would be observational. Okay. So the randomization, we had said before, when we can randomize things, so randomize a treatment or randomize a group of people we select, is it gives us what we consider like representative samples, but it also does things like it controls other variables that we have. So if we can, we do like randomized experiments because there are going to be differences past smoking between groups of smokers and non-smokers. People that smoke are likely to have other behaviors that go along with smoking. People who don't smoke are likely to have other behaviors that go along with not smoking. So observational studies are a necessity for situations like this because we don't want to force people to be smokers. But the data isn't always going to be the best for us. Partly because we're looking at people who have other things that can be contributing to their health here. So if you're a smoker, there is a increased chance you're also a drinker. So there's things that are going to have another effect here. So observational studies are really good for trying to figure out patterns. They're not going to be really great to tell us if a treatment actually does something though. So when we do randomized experiments, we're pretty sure that the treatment, if there's an effect after the treatment caused it. And observational, we're not so sure that the treatment has an effect at all.